Thank you, Rob. Good afternoon, everybody. So we'll switch gears a bit. I'm from Adva Optical Networking, and we're happy that we can present here this time. I will take you on a journey through the world of data centers, if I can find the clicker and the slides go up. Here we go. Good. I will start in a time when data centers have been really gray and static, and we move to today's time when they're much more colorful and agile, and also we will have a look to tomorrow's time when they're really colorful and really flexible and agile. So quite an interesting journey, I would say. But before I start, just a quick question. Are you guys all familiar with Adva Optical Networking and what we do? A few hands go up. If I ask the other question, then all hands go up? No. So we are a provider of connectivity systems, fiber optic connectivity systems, and that are based on two main technologies. So one is WDM, optical transport, and the other technology we have in-house is multi-service access. We use this stuff to interconnect many things, and amongst those things there are data centers. And in fact, one of our first customers more than 20 years ago was an enterprise, and we sold our systems to interconnect their data centers. And this is how we come into this data center interconnect business there. There's in the meantime market studies out there. So there's one from Ovum where Adva is rated #1 in metro data center interconnect with the optical gear. So, but yeah, let's start. Let's go a little bit back into time. If you look about 20 years back, we already had data centers at that time, quite a few. But most of them have been built for disaster recovery and business continuity. So it was more or less exact copies. They have been 20, 30, 40 kilometers away. Then there came 9/11 in the US, and then there was a requirement to put them even further away. And already at that time, those enterprises have been looking for dedicated data center interconnect solutions on the optical side. So you might ask the question, why didn't they use standard interfaces? For several reasons. So first, they had really weird protocols like SCON and FICON and the Sysplex timer and coupling links, so all of these mainframe protocols around. Second, for that time, it was quite high capacity, so started at several hundred megabits, goes up to 1 gigabit, peanuts for today's world. And this was really difficult to run over SDH networks, for example, so it was dedicated solutions based on WDM. And for those guys, what counted was high speed, bandwidth, so to say. Low latency was very important because most of it was synchronous mirroring, and the lower the latency, the higher the performance. And availability was a big concern, simply because if you're doing business continuity, it would be very good if your connectivity solution is highly available. So this was the old great times. Most of the data centers have been built for this. And then it changed a bit more than 5 years ago when the hyperscalers came in. So there's this acronym called FAMGA. Do you guys know what FAMGA is? It stands for Facebook, Amazon, Microsoft, Google, and Apple. So 5 of the big hyperscalers. And they built massive data centers. Totally different. And hyperscale not necessarily means it's big, it means also it's a totally different architecture. So in traditional data centers, we have a classical 3-tier architecture, servers, top of the rack switches, switching routing layer and routing layer. They collapsed it, like on this figure, just 2. And they simply did it in order to get the scalability, the hyperscale argument in there, so we can build data centers that are reasonably small in this architecture, but also huge facilities which are bigger than several soccer fields, if you want. So those guys came into the game, and suddenly data center interconnect was a totally different game for us. It's much higher capacities. They don't care about security and other things. They just want capacity, lowest cost per bit, totally different economics. And just to give you an idea how many of those data centers we have today in the world, it's about 350, and it's supposed to grow quite a bit, up to 500 in 2020. And interestingly, it's only 24 of those hyperscalers around in the world, 24 of those FAMGA companies. Interestingly, only 7 are headquartered outside of the US. How many are headquartered in Europe? Any ideas? Give me a number. 2? 1. In fact, it's 1. Does anybody know who is it? So I'm a German, I'm proud, SAP. Yeah, it's SAP. So there are a couple in Asia, like the Baidus and the Alibabas, Yahoo, Japan and so on. But most of them are coming outside of the US. And yeah, if your business is data center interconnect to a large portion, then you're wondering, is it a big chunk of it? Yes, it is, for sure. So if you look at those numbers coming from the Cisco Cloud Index, then it says by 2020, almost every second server we sit in a hyperscale data centers belonging to those 24 companies. Maybe we have 25, but then I don't know. Processing power, even worse, close to 70% in those big facilities. Almost 60% of data stored in these massive facilities. And more than half of the traffic is originating from those big facilities. So it's really, really representing a large portion of the data center infrastructure there. And this is why we are focusing a lot on this. Does the disaster recovery, business continuity thing disappear? No, definitely not. This is also growing, but this is a much bigger chunk there. So it's important, but it's not everything. Now, we might ask ourselves, why is this continuously growing? What's new? And we know a couple of those reasons. So we all talk about video consumption. It's getting even more than we thought about 2 or 3 years ago. So if you open websites in the meantime, videos just start running. Even if you don't click on them, you hover over them, zoop, pops up. It's maybe not like the old Daily Planet Harry Potter newspaper where we have everything on paper, so it's still electronically. But there's a lot of video, and it's a video native generation, what our kids are. So if I look at my daughter, how much video she consumes and produces and shares, amazing. We wouldn't dream of that. Cloud adoption, big topic. Yeah? So we are beyond the stage where people have been concerned about security. Regulation was a big issue. A lot of those things have been solved. Performance was a big issue, solved. So we have banks in the meantime. Deutsche Bank put about 30% of their data into cloud in the meantime. You have them from oil companies. You have healthcare companies. Basically every vertical is dealing with this. It's just growing. But it's more than that, in fact. So one thing which is coming and which is supposed to be really, really big is the Internet of Things. And the Internet of Things comes with another thing, which is big data. Because it doesn't help us a lot if we collect a lot of data and store a lot of data. We need to process the data in order to get some meaningful information out of it. Just having the data is kind of worthless. And yeah, if we need to do processing as quickly as we can, then yes, we need data centers. We need processing power. So the more things we have, the more processing power we need. Interesting. Then there's another race coming up here, artificial intelligence. All the big guys are playing here. If you look at Microsoft and Google, so Google, they produce their own technology. They call it TensorFlow. It's an AI-focused technology, and they made a statement that they already started to equip their hyperscale data centers with this technology, just to get the thing going. Microsoft, they went a little bit different, so they acquired a company, used to be called Maluba, doing pretty much the same thing, equipping the data centers with those processors and machines. They call it TPUs, tensor processing units. So you see, it's coming. It's cloud-based. It has to be cloud-based. And then there's another thing which I think is very interesting. So there are a lot of voices in the meantime out there that are saying, hey, Moore's law, that's slowing down. So especially Microsoft and Google are very vocal on that. And what does it mean? It means if it's slowing down, then performance becomes much more difficult to achieve, and performance is much more valuable. If it's more valuable, it's more expensive. Then enterprises most likely will not have the high-end compute stuff anymore because it makes sense to share it if it's expensive. Think about quantum computers and those things a few years ahead. So they will sit in big facilities to be shared with as many others as possible. So this will drive a lot of data center installations as well. So you will see there are a lot of effects driving this, and there's no end in sight today. Good. What we can conclude from this is it's fantastic to have 350 or maybe by 2022 500 hyperscale data centers out there, but that's not everything. because there are issues like security, issues like performance, issues like latency. And what we see already happening now is that there's a lot of smaller data centers being deployed at the edge, so kind of extending the edge of the internet, moving the power to the edge. And yeah, this is for several reasons. So we see this happening at the moment already with the big guys like Amazon and Google. So they started to deploy their server capacities, their storage capacities in co-location sites much closer to their customers. There's also others doing that. They're building own facilities in regions where they haven't been present so far. So in Bahrain, for example, Amazon just announced that they will open 3 data centers. Why is it 3? Suddenly redundancy is a big thing as well. So it's not only one big facility. And as said, it's about cost and performance. So if you need to transport everything over long distance, it's much more expensive than if you can transport it locally, obviously. Performance is something like latency, higher capacities, and those things. So it needs to move to the edge. Regulatory environment, another driver. So there's still data which is not allowed to leave the country. So you have to have something in country in order to offer your services. And also on the security side, it's quite important, because the less networks you travel, the higher the security, potentially at least. And so those smaller data centers, they still follow the hyperscale model from an architectural point of view, but it's many more of those, and they are further at the edge. Now, as many things are starting in the US, also this has started in the US a while ago, and there are some companies really focusing on that. And there's names like EdgeConneX, which really more or less suggests that it's edge data centers, 365 data centers, dart points, vExchange. That's the basis of the business model. Smaller data centers at the edge of the internet. But there's also the more established ones like Interaction, like Equinix we heard this morning, who are building smaller facilities and owning smaller facilities. And there are also really interesting exotic ones. So last year I had the opportunity to visit a data center in Darmstadt. So for those who don't know, Darmstadt, a city with about 50,000 people living there south of Frankfurt. And we used to have what we call a federal central bank. When the euro came, this bank became obsolete, and this bank used to store a lot of gold, in fact. So there's those nice facilities. At the end, it's a big safe, about 30 meters by 30 meters by 30 meters, walls like 2 meters thick. Nobody knows what to do with it. And there was an investor who thought, oh yeah, why not making a data center out of it? I can tell you, it's really, really impressive. So you get in and you have the banking financial environment. Everything marble stone, looks great. And then you see this big safe with servers in there, multiple stories, fantastic. So business ideas, because things need to move to the edge. Good, moving on. It's not only the colo providers, data center operators, hosters, cloud service providers, it's also the carriers that are jumping on it. They also have seen that, having data centers at the edge is important, and they have seen that they can have a play in that. So there's this guy from AT&T Labs, Andre Fuchs, and he said, hey, we are in a fantastic position there. We own a lot of facilities in the network. We have local exchanges. We have central offices. We have cell tower facilities with a lot of floor space capacity there. Why not using it and enable them to be edge data centers? So this is really happening, and many chimed in here. So 2 weeks ago, there was an event in Berlin called the MEC Congress, Multi-Access Edge Computing. And companies like Tele2 here from that region, companies like Telefonica, O2, they all chimed in and said, yeah, this is our future. We get out of this dumb, fat pipe thing, and we can have data centers everywhere. And interestingly, and then it comes back to us, if you have data centers everywhere, they somehow need to be connected. And we heard this morning from Equinix, that connectivity is a very interesting piece. Good, but it doesn't stop here. That's edge data centers. In the meantime, we talk about and we also see microscale data centers being deployed. I would say it's the inevitable consequence there. And one use case is the whole NFV environment, network functions virtualization, which started saying, hey, why not providing functions like firewall security functions, like WAN optimization in a virtualized way, software, run it on a server, have it at the edge, could be a customer, could be a multi-tenant unit, This is where it started. Everybody talked about, hey, deployment flexibility, everything is getting speeded up and fantastic. But in the meantime, they all figured out, hey, if we have this server there, we can use it for something else. And we can use it also to provide cloud capacity there, server capacity. So this is the extreme, the smallest one. And there's also things in the middle, not necessarily only in the carrier space. So a very nice example from my perspective is oil exploration companies. And what they used to do in the past, when they explored an oil field, they had to do some drillings. And if you do a drilling, then you collect an immense amount of data, terabytes of data. Now the problem is if you have a platform in the middle of the South Indian Sea, then it's quite tough to have good internet access there. So there's no fiber or there's no mobile network, no LTE, whatever. The only thing you can get is satellite access, but that's really slow. And that's really expensive if you want to transmit a terabyte of data. So what they did in the past is they used a ship, and the ship was going from one platform to the other, collecting the data on hard disk, drive it somewhere on the mainland into a data center, analyzing the data, concluding, and then telling the people, oh yeah, next drill you need to go a little bit left, different angle, whatever, deeper, not deeper, and then try to figure out how big the oil field is and how much is in there. So this was an endless process, and while the ship was going around, 2-3 weeks have passed. What those guys have figured out in the meantime is that edge computing is a fantastic thing, because if you pre-analyze the data you get from a drilling, then you can also reduce the amount of data by a factor of thousands, several thousand. And then suddenly the satellite link becomes a very interesting thing, because the amount of data is much, much smaller, and it's much, much cheaper to send it to a central place where all the data is coordinated, big data analysis, if you will. So you save basically 2 weeks, maybe even more, before you can perform the next drilling. So you see, also in the enterprise world, computing at the edge makes a lot of sense. Good, moving on. Now, of course, if there's something new, then there's also clever people who have ideas what to do with it. So if you only look at our smartphones, and if you look at them 10 years back, and if we look at them today, what our smartphones are all doing, it's the same here. If you have data centers everywhere, smaller ones, bigger ones, then you can do something which is called today fog computing. So you get a little bit of capacity here, a little bit of capacity there, and then you can do fantastic things for IoT, for 5G, for artificial intelligence, and those things. So there are already use cases, even though the infrastructure is not really there. So it will be more and more data centers, and as we heard this morning, it doesn't help us a lot if we have the data centers, we need to connect them. And connectivity, that's our business, and that's really important. A lot of bandwidth, low latency, high performance. Good, so looking at the data center world today or tomorrow, then we can look at this from two perspectives. So the one is saying, hey, let's start at the top. We had the big hyperscalers, the FAMGAs, building the giant ones. Then we figured out we need to move things to the edge because of performance, latency, cost, several reasons there. And then we thought, oh no, why not having micro data centers as well, complementing the whole model? That's one thing. The other perspective is, as the fog computing guys are doing it, is say, hey, if those things are more or less there, I can build my application taking all this into account from the beginning. So not one is driven by the other, but my application adapts to what is available. So services that need lower latency are performed at the lower layer. Things that have high compute effort, maybe at the higher layer if they're not so latency sensitive. And Hyperscale plays a big role in that, because Hyperscale is the basis, the architecture is the basis for all of those data centers, no matter whether they are giant, whether they're sitting at the edge, or whether they are micro. So they're all following more or less the same architecture. But the microscale data centers, they are changing the picture of how the services are delivered and how the data center is delivered. It's a multiple node model and not only one big thing anymore. So totally different world, and for us it means we need totally different ways to interconnect those guys, and we'll come to that. But before, let's look at the carriers. They're not sitting and waiting. So there's an initiative triggered by AT&T a while ago. It's called CORD, Central Office Re-architected as a Data Center. And what they basically wanted to do is say, hey, there's this fantastic hyperscale architecture, and those FAMGAs, they're saving so much money. Why can't we use it as well? Why can't we benefit from it? And in fact, this is exactly what they are looking at and what they're developing in this group, in this core group. So they defined an architecture on the hardware side. They defined an architecture on the software side, which is pretty much following the hyperscale architecture. So they're adopting it. And now look, if you have this there, and it looks very familiar and very similar to what the hyperscalers are doing, then you cannot only do what the carriers do today, which is connectivity, which is IP, which is Ethernet, whatever. You can also do cloud services on one platform. And as said before, they have one huge benefit. They have proximity. They have a lot of facilities very close to their potential customers. And many of the applications in the future we are looking at and thinking about today, like virtual reality, like augmented reality, like autonomous driving. So those are very latency sensitive services. And it will never happen that those services are provided from a very central data center facility somewhere in Dublin or north of Dublin. It will simply not work. So proximity is the key here. Good. Connecting the cloud. Of course, as said, nothing works without connectivity. And as we heard from Equinix this morning, for those guys operating data centers, it's not only space, power, and hosting anymore. So connectivity, in the meantime, is a key strategic component to the offering. And we help them. So we provide high-speed connectivity, multiple terabytes. We provide cloud access services based on Ethernet IP, based on optical. So we have solutions for all sizes of data centers and for all sizes of the applications. And it's not only that those guys are changing, it's also that we are changing. Because if you look at the gray and very static data center interconnect model for disaster recovery we used to adapt to 20 years ago, it's now much more colorful. So it's many more different applications. So we have content hosting, content distribution, we have virtual machine migration, we have many, many different applications which are imposing different requirements on the connectivity. So it's not this simple anymore as it used to be. You need different solutions, you need optimized solutions. Also in terms of topologies and technologies, disaster recovery was easy. It was point to point. It was maybe 20, maybe up to 100 kilometers, that's it. Now it's partially meshed, it's metro distances, it's long distances. It's different protocols that are now coming into the game, so a totally different environment as well. And also the operating environments are manifold. So it can be a managed service, it can be self-provided, it can be a single entity, it can be multi-tenant. So there are so many different options where connectivity needs to be optimized to. But it's not only for us, it's also for some other players in there. One thing we have seen now coming up more and more is SDN-controlled cloud connectivity. So what is this? It's not necessarily static anymore. There are many services that need, so cloud services, that need connectivity only for a small fraction of time. For example, if you move virtual machines. And you need very high capacity there, but the rest of the week you don't need it anymore. And if there's more, if there's a bigger pool of those who might use it, it makes sense to share it. And this is when comes agility, dynamics into the game. So the cloud itself is elastic, it's dynamic, it's agile, and the network should be as well. And I put here one slide we have drawn 2013, so about 4 years ago. And already at that time, we had a proof of concept with a university in the US called Marist University in New York area, together with IBM, and where we already have demonstrated this. So the cloud resources, basically the servers, they could trigger the establishing capacity and tearing it down again. At that time, a lot of people said, do we really need that? Today, we talk to a lot of cloud service providers that if I only could have this, and if only my service provider would support me with that, it would be fantastic. So times are moving on. But also for the service providers, it's changing. It's going much further beyond the traditional, let's sell to residentials, to business customers, and some carrier wholesale. It's now a new community of potential customers there. It's the cloud service providers, it's the hosters, it's many of those content providers. They have different requirements. They want different connectivity, not the old static thing anymore. They want connectivity which is optimized to their business needs and to their business models. So it's an entirely new environment popping up there, and I think it's exciting. Everything which is new, at least to me, is exciting. It's much better than doing the same stuff again and again. And since there's a lot of excitement, it's also kind of a new business idea, and we have seen a couple of carriers popping up in the meantime, so they either have fiber from utilities, or they lease it somewhere, or they even build it. And their core business is interconnecting data centers in a certain region. And they focus on those new types of customers. They focus on their requirements. They have totally different tariff models. A classical carrier has not in place today. They have this agility in their mind. So this is really a new business segment in the service provider, network service provider space, which is popping up, which is really, really interesting. Good. Nothing without predictions, and I'm usually not very shy in giving predictions about the future, for those who know me. Where will we be in 3 years from now? Maybe in 5 years from now, in terms of data center interconnect. The first thing I think is very easy. Since we are re-architecting so many facilities, central offices, whatever it is, following the hyperscale model, everything will look like data center. So in 3 years from now, maybe 5 years, is all data center interconnect. We're only interconnecting data centers. At least everything looks like the same. And with that, those studies from the analysts now breaking out, hey, what goes into infrastructure, what goes into data center interconnect, I think it will end up with 100%. So this business model will be somehow obsolete. What else? Capacity growth will continue. There are studies, we heard it also this morning, it's something between 30 and 50% per year. There will be no end. So we have customers that are using terabits and terabits between two facilities. So some of the hyperscalers, for example. It's multiple fibers, 96 wavelengths with 100 gig or 200 gig services running over it in parallel. It will just go on. So there are people out there who say we need at least 40 terabits per fiber. There are others like Facebook, they buried in one location 20,000 fiber pairs between their data centers. 20,000, imagine what you can do with that. So people are planning for that. What else will happen is we will see different granularities. We will see these big pipes, but those smaller pipes will not go away. There's still many, many, many consumers of capacity out there where 1 gig is sufficient, where maybe 10 gig is sufficient. But there's also those who need 100, who need 200, 400, a terabit. So we will have different granularities. And this is one thing we are looking into with our solutions, of course. How can we support them in an efficient way in one infrastructure piece? Very important. And then, last but not least, I mentioned it already, the more we have from that, the more it makes sense to share it. So bandwidth on demand becomes more or less an important piece of it. Today it's SDN, that's the magic word there, and we believe it will go on like that. So many control models inside the data centers and also control models we are using now for network infrastructure are very similar from a stack point of view, from an architecture point of view. So you can easily link them together and you can use the clients to automatically request bandwidth, provision it over the network, release it again, share it, use resourceable multiple times, increase efficiency. So those are my 4 predictions for today. I might have more when I speak next time. Not today. I have to say thank you for your attention. I hope you like the journey through the world of data centers. As I said, I think it's colorful. It will be even more colorful in the future, more agile. And that's the end. Thank you.
So if there's anyone got a quick question, we have 2 minutes. Microphone at the back, please.
Hi, Magnus Huss from Interaction. Thank you for mentioning us. I have a question. We still hear about customers, not very large customers, but ordinary large Nordic customers still looking into building their own data centers. Why would they do that?
So what we see is, of course, there's this one class of enterprises, for example, from the financial vertical, for them it's all about security, owning their own thing, very important. This is hard to convince them that they should outsource everything. So not everything goes to the cloud. There's still, with some data, especially from the financial vertical, or from other verticals, there is the notion of, no, can't go to the cloud, can't get outsourced. So this is still there. And then sometimes it's also an economic reason, where they look at plan A, plan B is cheaper, let's go B. It's like with connectivity, so we are facing the same. So sometimes those enterprises come to us, or data center operators come to us and say, hey, or interconnection point operators, IXPs come to us and say, hey, I have fiber, I want to have your equipment. Sometimes they say, I go via carrier because for me it's used better, I don't have the expertise or whatever the reason is. Yeah. So I'm not saying that everything will go into cloud. So I think it will take a while. But those things where the cloud is beneficial in terms of compute cost, compute capacity, in terms of scaling it up flexibly up and down. So there's many, many reasons why things go into the cloud. It's simply more flexible in nature.
Okay, that's all we have time for. Could you join me in thanking Michael once more?
You're welcome. Thank you.
Thanks.